Hi there. So for today, we're going to talk about the NormalCDF functionality in your calculator, and that is going to be used when we have problems involving normal distributions. So I have here an example. The diameters of coffee beans in Daegu are normally distributed with a mean of 6.1 and a standard deviation of 0.88 millimeters. So before we start, it would be helpful for us to write this in proper mathematical notation. So we're going to say that, for example, the variable of the diameters is denoted by x. We say that it's normally distributed with a mean of 6.1 and a variance of 0.8 squared. So remember, the notation is going to be involving the parameter for variance, not the standard deviation. Okay, so ideally you should be graphing a normal distribution curve and saying that you have 6.1 as your mean and some indication that the standard deviation is equal to 0.8. Okay, so if I take a look at the first question, what's the probability that the diameters is less than 5 millimeters? Notation wise, I should say the probability of x less than 5. Okay, and I'm going to go to my calculator to input what I need, and that will be using second vars, which will bring me to the distribution menu, and I choose NormalCDF. Okay, we will never use NormalPDF. So you identify the lower boundary, so it defaults to -1 times 10 to the 99. So we're not touching that. We're just going to set an upper bound, which is 5. Okay, so the mean is 6.1 and the standard deviation is 0.8, and that's our answer, 8.46%. So we're going to say 0.0846 to 3 significant figures. So if you were to draw that somewhere here, x less than 5, maybe this is the area that we actually are referring to. Okay, for the second one, if we want the probability more than 7, so around, let's say this is 7. Oops, let's say earlier that was 5. So this is 7. This is the probability that we want. So notation wise, it's P of x greater than 7. And we go back to NormalCDF, and the lower bound will now be set to 7. So the upper bound is defaulted as 1 times 10 to the 99, but you could just put like as many 9s as you want, easier to input. So you can identify that probability to be 13.0%. So 0.130 to 3 significant figures. Okay. The last example here is, what if we want the probability that it's between two values, 5 and 8, for example. Okay, so I can say between 5 and 8, so that's my 5, my 8 is somewhere here. So the area that I actually need is this orange area, and I can go to my calculator and write both the lower bound and the upper bound. So 5 and upper bound is 8 over here. Okay, so notation wise, I'm looking for the probability that x is between 5 and 8, and that's equal to 0.907 to 3 significant figures. Note that we are really not concerned with the inequalities being strict or non-strict, simply because this is a continuous variable. So whether you write it as non-strict x between 5 and 8, inclusive of both 5 and 8, the probabilities will be the same.